Okay, so let's look at this question right here. It says x plus 5 in brackets, which is squared. So I hope at least that I'm not the only one who, when I was in like 6th grade or 5th grade, thought that this would be represented as x squared plus 25, because that would be incorrect. When you have something like a binomial in this case, because there are two terms, this term and this term, that's in brackets and squared, you can't just square each term individually, because that would be this instead. It would not be this. So what exactly does this look like? It's basically written as this, because you're taking this term and multiplying it by itself. When you do this, you don't just multiply these two terms together and these two. You actually have to, let me just write it out again because it's kind of messy over there. You have to multiply the x by the x over here again by the 5, then the 5 over here by the x, and then the 5 by the 5. So you actually multiply 4 times. This is known as a quadratic, actually, because you use when you factor it out, it gives you two distinct binomials. Anyway, moving on back to the subject. When we evaluate this, when we do the first one, which is x times x, that gives us x squared. When we do this next one, which is x times the 5, these two, then that would give us 5x. Then these two over here, or let's do it like this, from underneath these two, would give us another 5x. And then this one like this would give us 25, because that's 5 times 5, which is also referred to as x squared plus 10x plus 25. So we can see the difference between these two is that this one has the 10x over here that we missed out earlier by multiplying it individually. So I guess it works pretty well to just write x plus 5 squared like x plus 5 times x plus 5 and multiply each term individually. But what happens if we have x plus 5 cubed? We can't just go and, we could just go actually, just do this. But then what happens if we have x plus 5 to the power of 7? Are we going to write that same thing down? Are we going to write x plus 5 down, x plus 5, all the way to x plus 5 for the 7th time, and then multiply every single term by every other term? This term, this term, this term, this term. That would be very much a painstaking method that would probably be very inefficient. You probably wouldn't even have time probably wouldn't be able to even do it in 20 minutes, because there would be such a long chain at the end that would require so much simplifying. So, what does that mean? We can use something called the binomial theorem. Let me just erase everything over here. So what is the binomial theorem? The binomial theorem is a shorthand way of representing multiplying two terms when they're all raised to a power. Okay, so before we actually look at how what the theorem is and how it works, there are a few rules that we should first know about the binomial theorem. Number 1, the number of terms is always 1 greater than the power in which the binomial is raised to. So if we have x plus 5 squared, for example, for x plus 5 to the power of 1, for example, that gives us x plus 5, which is 2 terms, which is 1 greater than this term here. If we have x plus 5 to the power of 2, as we evaluated earlier, it's x squared plus 10x plus 25, which is 3 terms. We could go on, but it would become a lot more complicated to evaluate individually, and it would become a very long video. So essentially, when we have a plus b to the power of n, the total number of total terms is equal to n plus 1. Now, rule number 2. This one we'll need to use a plus b to the power of n to prove. Essentially, it is that it follows Pascal's triangle. So Pascal's triangle is essentially a triangle that goes like this. It's a pattern in which the last row, like here, down here, is always 1. Down here, it increments by 1. And then down here, it's also always by 1. So it's like, it's a very palindromic pattern. So this next one would be 1, 3, 3, 1. And it would keep going down like that. Then it would go 1, 1, 4, 6, 4, 1, and so on and so forth. So essentially it follows Pascal's triangle in this sense, because when we have a plus b to the power of, let's say we have a plus b to the power of 1, it just gives us a plus b. Currently, we only have 1 here. We don't have the 2 term over here. But when it's raised to the second power, a plus b to the power of 2, it gives us a squared plus 2ab plus b squared. You can check that over here. But long story short, this follows this row of Pascal's triangle. It follows the 1, 2, 1 structure. A plus b to the power of 3. That goes a cubed plus 3ab plus, 3a squared b plus 3b squared a plus b cubed. Essentially, it again follows the next row. It keeps following this kind of pattern. This is another one of the patterns of binomials, of the binomial expansion that gives the binomial theorem. So these are the 2 main rules that we should first know before moving on to actually what the theorem itself is. I'll just erase it real quick. Okay, so to the actual theorem itself. So it may look unfamiliar to you at first, but essentially a plus b to the power of n is equal to n, and then this is a Greek letter here known as sigma. If it'll let me draw properly. Yeah, this is that sigma. So basically sigma is a Greek letter that means the sum of. And then let's say we have here r equals 0, and that n choose r. This here is combinations, which you may remember from our last video on this topic, which is why it's also in this folder, times a to the power of n minus r times b to the power of r. So first let's start off with this section, which is probably the most confusing of the lot. What does that mean? So it means that r will keep increasing by 1 until it reaches n, and then the sum of all those terms will be equal to this. So when r is 0, this is first inputted into this set right here. So when r is 0, it would look like n choose 0 times a to the power of n times b to the power of 0, because we just put r in there, which is also referred to as a to the power of n, because b to the power of 0 is 1, and n choose 0, as we reviewed earlier, was also 1. So just leave a to the power of n. So this would then increment by 1, so this would become, r would become 1, and now we'd have n choose 1 times a to the power of n minus 1 times b to the power of 1. And slowly we would keep doing this until it reaches n, which would be, for the final term, n choose n times a to the power of 0, because a to the power of n minus n essentially would be because it's n minus r, but since r and n are equal, now a does not exist. It's now 1 again. This is changed to 1. Then we have b to the power of n. So slowly it starts to make its way through the entire sequence, but this is a much easier way of collecting all the terms, because otherwise we would have a very long string of terms that would take a very long time to multiply out and then simplify in the end. So this is the binomial theorem. Let's give an example to show how it actually works. Let's take our original example, but let's raise it to a much higher power. Let's raise this to the 6th power instead of the 2nd power. We're using binomial theorem. We can just we can start with r is 0 and n is 6. So that's 6 choose 0 times a to the power of n minus r. So n is 6 and r is 0 currently, so that's a to the power of 6 times b to the power of r, and r is 0, so b to the power of 0. These get cancelled out because they're both equal to 1, so it's equal to a to the power of 6. And in this case, because it's written in the form a plus b to the power of n, a in this case would be x, which would mean that the first term is x to the power of 6. Then we would do the second term, which is 6 choose 1, because r is increased by 1, times a to the power of 5, times b to the power of 1. And we know that a is x and b is 5, so it would be 6 choose 1 times x to the power of 5 times 5, because that's b. Now, if we were to use our calculator, we would know that 6 choose 1 is equal to 6. So that means that we have 6 times 5 times x to the power of 5, which means the next term is 30x to the power of 5. And we would keep doing this. Let's do this for one more term. Let's say we're doing it for the next term. So that'd be 6 choose 2 times a to the power of 4, because it's decreasing by 1 again, times b to the b squared, which is equal to 6 choose 2 we know is, let me just do it real quick on my calculator, I think it's 15. Yeah, 6 choose 2 is 15. Then that's multiplied by a to the power of 4, and a is x in this case, so it's x to the power of 4. And then it's multiplied by b squared, which is, so b squared is 5 squared, which is 25. So the next term is 25 times 15 times x to the power of 4, which is equal to 375 to the power of x. This is 375 times x to the power of 4. So we keep going like this, and essentially this simplifies it in a much easier way to represent for future problems. Now, you might be wondering, how do the initial patterns that we had looked at actually link to this binomial theorem? How does Pascal's triangle have anything to do with it? Well, if we look at the number of terms, so let's say let's take our original example actually, x plus 5 to the power of 6. So we know the number of terms will be 7 because that's 6 plus 1. So now, if we look at the 7th row of Pascal's triangle, it is 1, 6, 15, 20, 15, 6, 1. Essentially, the part where it goes n choose r links to this in the binomial theorem. In this case, let's start with n is 6 and r is 0. 6 choose 0 is equal to 1. So that links to this term here. 6 choose 1 is equal to 6. That links to this term here. And then 6 choose 2 is 15. 6 choose 3 is 20. Essentially, it ensures that these initial values are maintained, and then it's multiplied by the actual things related to it. So that's just how Pascal's triangle links, and how the combinations ensures that it's added in there, because otherwise we may forget these, and it could give us wrong values. And yeah, other than that, that's the binomial theorem. This will link to this term, then 6 choose 4 is equal to 15. Yeah, and it will continue so on and so forth. Now, why don't we do a practice one to see if we've actually grasped the concept. So let's an easy way, just to add on, to look at it, would be if you have a plus b to the power of n, you just know that it starts with n choose 0, and then you multiply by a to the power of n, and then b to the power of 0. And then you keep increasing b by 1, and you keep decreasing a by 1, and you keep increasing r over here by 1. And then you can keep doing that for each term, and that's a very, very efficient way of doing it. You do get it in the add math exam, you do get the equation of you get the binomial theorem, so it does make it a lot easier, but this is just a much simplified way of the binomial theorem itself, much more simplified way of looking at it. So let's just do an actual problem here. Let's do 3 plus x to the power of 4. So pause this video if you want some time to try and get all of the terms within the sequence. If not, if you still don't think you're up to it, we can just go through it together. And when you're ready, play the video again and we can go through the answer. Okay, so let's just assume that you're either just waiting for the rest of the video to finish, or you've just done the problem and are waiting for the answer. So in this case, we just first identify that 3 is the a value, and x is the b value, and 4 is the n value. before we continue. Now, as per our binomial theorem over here, we get 4 choose 0, because we're starting at 0, and then it will work our way all the way up to 4, times 3 choose 3 to the power of 4 times x to the power of 0 is our first term. We'll leave it unsimplified, and we'll simplify everything together later. Plus 4 choose 1. See, the plus here represents the sigma that was in the earlier equation. Plus 4 choose 1 times 3 to the power of 3. We're decreasing it by 1 times x to the power of 1. We're increasing this by 1. Plus 4 choose 2 times 3 squared times x squared. Plus 4 choose 3 times 3 to the power of 1 times x cubed. And then our final one, which is 4 choose 4 times 3 to the power of 0 times x to the power of 4. As you can see, I've just been decreasing this one by 1 continuously, and increasing this one by 1 continuously, and increasing this one by 1 as well. So let's just evaluate each of them and simplify them. So 4 choose 0 we know is 1, 3 to the power of 4 we know is 81, so right now we have 81. X to the power of 0, remember anything to the power of 0 is equal to 1. So 81 plus, and then 4 choose 1, we can just use our calculator. 4 choose 1, which is equal to 4 times 3 to the power of 3, which is 27. That's equal to 108. And right now we have x as well, so it's 108x. Plus, and then 4 choose 2, which is equal to 6 times 3 squared is 54, but we multiply by x squared. Then we add it to 4 choose 3 times 3, which is 12x cubed now. And then our last term, which is 4 choose 4 times 3 to the power of 0. But that's also just, these are just 1, because 4 choose 4 is 1, 3 to the power of 0 is 1, so that just leaves us with x to the power of 4. So that means 3 plus x all to the power of 4 is equal to this. And it is so much easier than having to do 3 plus x times 3 plus x times 3 plus x times 3 plus x. And having to evaluate, we were first having to multiply these two together, then multiply all of this by this, then multiplying all of this by this. It would have just taken a very long time. The binomial theorem makes it much easier to understand. So let's just do one final problem to ensure we've got it. So let's say we have 2 plus 1 over x. So careful here, it's 1 over x, not just x. Let's do this to the power of 8. And let's say we have to find the first 3 terms, so we don't have to go all the way. That would mean first 3 terms. Pause the video if you would like to attempt it. I'll attempt it now. So, identifying first, 2 is equal to a, and this is equal to b, and 8 is equal to n in this case. So the first 3 terms would be 8 choose 0 times 2 to the power of 8 times 1 over x to the power of 0. So remember, when you're raising this to the power, you're not just raising the 1 to the power or raising just the x to the power, you're raising the entire thing as a whole to the power. So these two are just 1, so that's 2 to the power of 8, plus 8 choose 1 times 2 to the power of 7, we're decreasing it by 1, times 1 over x to the power of 1. And then we multiply that, we add that, to 8 choose 2, which is this is our final term, 2 to the power of 6, decreasing by 1, and 1 over x, increasing this by 1 to make it squared. So let's evaluate this. So 2 to the power of 8 is equal to, let's use a calculator, 256. And then 8 choose 1 is 8, times 2 to the power of 7 is 1024. This is 1024, and then over here 8 choose 2 is 28, and then we multiply by 2 to the power of 6, which would give us 1792. So now we have enough information to actually solve it. So we have 256, because that's this, plus 1024 over x, because we're multiplying it by this now, plus 1792 over x squared, because this has been squared as well. So this is our answer for the first three terms. Questions might also ask you to do in ascending powers of x or descending powers of x. This way you can actually manipulate where you put a and b. So let's say they want you to do ascending powers of x. Then you would write it in this form. If they want you to do descending powers of x, you would write it in this form. Either way, the one that'll be ascending is, the one that'll be ascending is this one, b, and the one that'll be descending is a, as per this. So yeah, that's how the binomial theorem works. You can use it to evaluate these kind of binomials easily. We'll go into some practice problems that have some very interesting variants of these kind of questions. They're not just going to ask you to evaluate this. They're going to maybe ask you to multiply by another binomial. But either way, it should be pretty okay. I'll be able to guide you step by step. Whatever the case, I'll attach some worksheets at the bottom of this video. If you have any questions around this, do let me know. Anyway, I think that's it. So thanks so much for watching, and see you next time.